So now that we've created our hierarchy and we're able to access this hierarchy and pull data out of it, what I'd also like to do is be able to create new symbols dynamically within my objects, and I would also like to assign new values. So again, we're going to be using the console, and you can run along with me. And so what you have is the car, and you can target the car, and you know that this is a variable. So car itself is an object, but you could actually assign a whole new empty object, or you could assign a string or anything else. So it would actually delete out this object, and it will assign a string to the car variable. Now when I call up car, you'll notice it's a string. It deleted this object for a string. So that's entirely possible. Now on top of that, what if I just wanted to change one of the values, such as the string Volvo that's being logged out to the console? How can I actually change this? Well, what you need to do is you need to, again, target what you want to assign. So last time we targeted the entire car hierarchy object and we deleted that and we replaced it with a string. But now what I'd like to do is I'd like to target a member called make. And now we're targeting this member, we can assign a new string such as Ford and with a semicolon. So it's going to target this symbol in memory, and it's going to look at this value and it's going to change this value for the string Ford. And there we go. So we have car.make equals Ford. And now if you take a look at car, we still have the object here, but the make has now been changed to Ford. Now also, don't forget there are other assignment operators that we can use. So for example, we know that car.make contains a string, and we know that we can use the plus equals operator. So we're going to concatenate because we already have a string here, and whether there's a string on the left side or the right side over here, it will convert it into a string. I could even put in a number right here, such as 200. And when I do that, you'll notice it converts the number into a string, and there it is, Ford 200. And you take a look at the car object, there it is, make Ford 200. So that is also the assignment operators. Don't forget about the other assignment operators for mathematics and so forth. So for example, you have car.speed. And again, you can access it this way, or you could access it with the brackets like so. And we can say, for example, times equals 2. So 2 times 160. And that's going to leave us 320. Take a look at car. There's car. The speed is now 320 miles an hour, fastest car on the planet, Ford 200. There you go. And you can also reassign, let's say, objects as well. So we've got this engine object. Let's just very quickly say we're going to take the engine out. So I'm going to say engine equals, and then you can assign a new engine. We can set that to new. And when we do this, take a look at car. You'll now notice that we have engine, and it's replaced this object with this significantly less complicated object that just has a property new engine. So that is pretty cool. And you can even reassign, let's say, the methods. Don't forget, this is just a symbol name pointing to a method or subroutine or function. So for example, you could say car.drive equals, and then I could just say drive. Since this subroutine doesn't really do much, it just has the string drive. So now when I look at car, it is no longer a function, it's just a standard string that's nice and easy. But how do you create, let's say, a new key? Well, how do I do that? Well, we're starting out with car again, fresh, and we've got drive as a method, you've got the engine object, make and speed. But let's say that I would like the model. So how do I put the model in here? So I'm going to say car dot and then model. You can think of this like saying var model. You're creating a new symbol name because this symbol name currently does not exist within this object. And then what we can do is we can assign a new model such as V60, for example. So car.model equals V60. Let's go ahead and do this. And now when I take a look at car, you'll notice that it actually created the model symbol and it has the value of V60. So that is how you create, just like you would create a new variable, that's how you create a new key name, a new symbol or memory pointer within this object. Very nice. Now also, what you could do is say car.color, for example. And let's say that I don't even put anything in here. I don't assign anything. Car.color. Well, you'll notice it just says undefined. Sorry, I didn't find that property. And if we take a look at car, you'll notice it didn't actually create that property. So you need to make sure that if you want to create it, you can't just create it like var color, for example. That will create a variable called color, and that variable, that symbol, will exist, but it will be undefined. If, however, you want to create a symbol name, a key name, inside of an object, then you need to assign it right then and there. So I can say car.color is equal to red. And only at that point, when you assign a value, will it actually create that symbol inside of the object, color red. That's how you create a new property or member but we can also create new methods as well if you would like. Just treat it the same way. So car.stop. This doesn't currently have a symbol link inside of our object. And then we set it equal to, so we want to create it, and then we want to create a function, for example, that will return the string stop. And when I do this, I can hit return, and then if I type in car, you will notice that inside of car, we now have the stop method. Also, you can add and change things inside of the engine object. So for example, we can say car.engine.stop equals pretty much the same function again. And we could say stop engine this time. And then when we take a look at car, open up engine, we targeted the engine, then we actually created a symbol called stop that didn't exist, and we set it equal to this subroutine. And this is now a method in our engine right here, this stop. So that is actually very easy to do, and you can change values in the engine and so forth. So I can clear that out. So that's how you create methods. Now finally, how do you delete certain members? So when I take a look at car, let's say I no longer want color. How do I get rid of this property? Well, if I set car.color equal to null, well, that won't get rid of it. It will nullify it in a way that it won't have a value. It'll say there is no value, but null is still a value, and this symbol link is still here, and it's a waste of time being here. So how do we completely remove it? Well, what you do is you use the delete operator, and then you define the symbol link that you want to delete, such as car.color. It will find that symbol link right there, and it will just simply delete it out. Now, this operator delete is a function, don't forget, in the JIT compiler, and if it manages to successfully run its operations, then it will return true. If it couldn't delete the particular property or method, it would say false. Sorry, I can't delete it. So it did manage to delete it. Now I can say car again, and now you'll notice there is no color property. It's been completely removed. This symbol link has been completely wiped out of the memory map. Now, finally, what we can do is you can also delete methods as well. So you could say car.stop. So we can delete that method that we created, hit return, and then you can say car again, and you'll notice that method has been removed. We only have the drive method from now on. So it's pretty much a death trap for a car. So that is how you assign, create, and delete members within a standard object. Arrays, however, are a little bit different, and we are going to take a look at modifying our array in the next lecture.